Okay, good afternoon, everyone. Thanks for joining us. Today's webinar is going to be an overview of using our thermal cameras for fire prevention, focusing mainly on waste recycling sites. My name is Mark Adams. I'm a product pre-sales specialist for Hikvision, and I'm joined today by Michael Dye, our product manager for the thermal cameras. If you have any questions as we go through the presentation, please type them into the chat box and Michael will answer them. Now, the fire brigade attend over 300 fires a year at UK waste sites. This costs them around £16 million. That's just the cost for the fire service. It doesn't take into account the cost of the damage caused by the fires themselves. Clearly, the best way to reduce this is to stop the fire from ever starting in the first place. That's where our thermal cameras can help. They don't detect a fire, they detect hotspots that build up before a fire. So what we're talking about is fire prevention rather than fire detection. Once a fire has started, the entire site could be destroyed within minutes. It's too late to do anything about it. But hotspots start well before the actual fire, generally 1 or 2 days before, meaning that by detecting the hotspot and dealing with it promptly, the fire never has the chance to start. There were all sorts of waste products stored on these sites, which are at high risk of causing fires: batteries, gas cylinders, chemicals, and much more. In many cases, these are piled up in large open areas. Traditional smoke or heat detectors just aren't going to work. Even indoors, these older solutions can be quite limited. For instance, using a smoke detector in a large building with the detector on the ceiling, the smoke from a fire could take a long time to reach the detector, by which time the fire could be well established. Thermal cameras can easily cover a large area, and they give you advance warning so you can take action to prevent the fire rather than reacting once it's started. You can also set flexible rules to send alerts when a specified temperature is exceeded. Some of these cameras are bispectrum. They have an optical lens alongside the thermal one, which means you have a way to visually check the scene to see what's happening, as well as recorded video evidence of the event. Here's a few other benefits of our thermal cameras. They can monitor the temperature of specific areas or even pieces of equipment from a distance without interfering with people working in the area or the operation of the machinery. We can display the maximum temperature of an area on screen, or even show different temperatures as different colors, making it easy to see any potential problems or danger areas. As I already mentioned, because we're detecting temperature changes, we have an early warning system that lets us react before a fire starts. We can also set multiple rules. For example, we can monitor the difference in temperature between 2 regions, or even warn when a temperature is too low. And of course, thermal cameras don't need visible light to work, so it's simple to monitor an area 24/7 and with the ability to receive real-time notifications. We have a specific product range that is recommended for fire prevention. These are called thermometric cameras. They have more accurate temperature measurement than the standard security thermal cameras. They're accurate to plus or minus 2 degrees C, compared to the standard thermal cameras, which are accurate to plus or minus 8 degrees. They can also detect far higher temperatures. They have a range of minus 20 to 550 degrees C. The standard thermal cameras have a range of minus 20 to 150. You'll see the part codes in a couple of minutes, but they all have the letter T in them to show that they're thermometric. This T version is always recommended for fire prevention. If you do use the non-T version, the maximum temperature alarm needs to be lower than about 120 to 130 degrees. Although the cameras can detect temperatures up to 150, your alerts need to trigger before you reach this level. And depending on the site and what potential heat sources there are, you may need to set alarms at 200 to 220 degrees C. So the thermometric camera is going to be essential in this case. Now let's have a quick look at the rules. We can measure the temperature of an area, a line, or of a specific point. The cameras support up to 10 areas, 10 points, and 1 line. But for waste sites, use the area. It's the most flexible option because you can trigger an alarm when any part of the area exceeds the set temperature. The line is used for automation processes, and point is generally not used. You need to be very, very specific about exactly where you're putting it. Now, color highlight, also called isotherm, is really useful. Here we're using white hot mode, which means that the hottest parts of the image are shown in white and the coldest parts are in black. Now we can set the camera to use a particular color to show anything in the scene which is over a set temperature. So in the example here, we're highlighting in red anything that's over 40 degrees. This is a great visual reference. It doesn't necessarily have to trigger an alarm. Of course, you have that feature too. You can get real-time temperature alerts through to Hike Central, Hike Connect, and IVMS 4200. The cameras also have physical alarm outputs, so you can connect to other equipment to trigger alarms and so on. This is very commonly used on waste and recycling sites. If you want reports on historical temperature data, then you can use Hike Central. An issue that sometimes occurs is false alarms where the exhaust pipe from a forklift or a similar vehicle working in the area is hot enough to trigger your temperature alarm. In the example here, the exhaust pipe is about 130 degrees. So if you have an alarm set at 100 or 120 degrees, which you might well choose to do, then this will obviously trigger the alarm. So we developed an algorithm that can detect that the heat source is from the vehicle and ignore it. This is available in custom firmware if you need it. In this first video clip, the camera is detecting the heat from the exhaust as being the hottest part in that area, and it's displaying that temperature up on the top right. In the second video clip, you can see the exhaust is still highlighted in red, but the maximum temperature display is now ignoring it and showing the maximum temperature for the rest of the scene. Something else that can cause problems for thermal cameras is highly reflective surfaces like polished metal. On the top left picture, you can see a very bright reflection in the van in the middle. This is sunlight being reflected from the metal on the side. On the thermal image on the right, you can see the camera's detected this as an abnormally high temperature and the alarm is triggered. This is something that affects all thermal cameras. With our bispectrum cameras, the optical channel can identify this reflection, and if the thermal camera detects a hotspot in the same location, we know it's a false alarm, and it simply gets ignored. In the next version of the firmware, the on-screen display will actually show that that alarm has been filtered out. Now, if you have multiple areas to cover, in many cases, you can use one PTZ. But to make sure all the areas you need to monitor are properly protected, you need to set the PTZ up correctly. You must use the presets and have the PTZ stop at each monitoring point for at least 30 seconds. We strongly recommend using an absolute maximum of 10 presets, which means that every area is being checked once every 5 minutes maximum. Depending on the site, you might need to use less presets, so you get the complete sweep done more quickly. If you're just monitoring a single area, a bullet could obviously be used instead. But if there's any chance that the area you need to monitor might change over time, perhaps as the site develops or grows, then a PTZ is actually a better choice because it's much easier to adjust it in future to cover the new area. And here's the current product range. There's different lens options for each of these. As I mentioned earlier, these are all thermometric and have the letter T at the end of the part code. Do be careful because there are non-thermometric versions of these same cameras. They have the same part code, but without the T at the end. And of course, they're not as accurate. So we have two fixed bullets. The 2.1 version is purely thermal, and the 2.6 version has both thermal and optical lenses. Then we have two PTZs, the 4.1 and 4.2 series. The 4.2 series is from our Deep in View range, and it supports smart tracking. We also have a positioner for situations where you need to monitor very large distances. And the data sheets for all of these cameras will tell you the maximum distance that they support for temperature measurement and for other VCA functions. And lastly, we have our Cube camera. This is intended for monitoring temperature of equipment or machinery, and it works at a much closer range than the normal thermal cameras. There may be machinery in some cases worth tens of thousands or even more on sites like these, so it's important that those are protected as well. You need to use an I-series NVR with all of our thermal cameras. If you use a K series, you'll be able to see the image, but you won't get any of the temperature information. And of course, as we saw before, you can use Hike Central, Hike Connect, and IVMS 4200. Now, in some cases, insurance companies need proof that products have been certified for use as heat detection systems. The models shown on here have all been certified by CNPP. They're an independent authority, and their certification is recognized in the UK and right across Europe. And this can really help in cases where you're trying to win a job where they want certification and need confirmation. So a few different examples of where these cameras are out in operation at the moment, obviously landfill sites, incineration plants, and in areas of energy recovery. This is a recycling site in Preston. There are piles of waste products all over. In this case, it's cars that have been scrapped. And here they're using that isotherm, the color highlighting feature that we saw earlier. And here, green is being used to indicate a slightly high temperature, worth being aware of, but not actually a safety issue. Higher temperatures are shown in orange. And this might be a pre-alarm in the daytime because it's just due to sunlight, as we saw before. But at night, this same temperature could mean a full alarm. And then red, which happily we can't see in this example here, could be a full alarm all of the time. And you can have up to 3 temperature ranges and therefore 3 different colors. This was a large project over in France, a large number of waste recycling sites. The main camera is a thermal PTZ covering the majority of the site, but we also installed a thermal turret to cover a few specific areas. In this particular photo on the left here, it's actually covering a conveyor belt. Now, I mentioned that we recommend using the T versions for greater accuracy. In this particular case, the turret isn't yet available in the T version. It will be out sometime later this year. This particular example, that was fine. The accuracy for the conveyor belt that we're monitoring was okay without the T version. And then a couple of other projects that have been done recently as well. So this was a landfill site in Slovenia and also a recycling plant over in Spain. And finally, to help you select the right thermal cameras and the layout for your site, we have our thermal design tool. Now with this, you can upload a map or a plan of the site. You can add the required cameras and get a nice visual representation of the coverage you're going to get from each camera. Obviously today we've been focused on fire prevention, but you can use the same tool to help design a system for perimeter protection. And Michael's now going to show a brief demonstration of how to use the thermal design tool. Thanks, Michael.
Thank you, Mark. So good afternoon, everyone. Can I have the permission to share my screen, Mark?
Yeah, thank you.
Okay, cool. So now I'm going to show you how to use Hikvision online thermal design tool. So we have to find our online thermal design tool. So if you go to Hikvision official website and go to the support section, and here is a tool, and here is desktop, online, and Hikvision app. So go to the online tools, and then select the thermal design tool on the page. Okay, and here are a lot of useful tools for you to use for CCTV selections, like the optical cameras, lens selection, thermal design tool, storage, and network. Today we focus on the thermal design tool, the second one. So if we go into this one. Okay, so now you can start your thermal design tool design. So the first step for the thermal design tool is to import a map into the solution. So usually you can import a project map, or you can also do a site map based on the Google Maps. So what I did just now is I just did a crop screenshots of the Google Map, and on the Google Map, there is a function it's called measure distance. So you can just measure a distance like the 100 meters or 200 meters, and then just do a screenshot. So you will see how long this distance is. And the second step is going to set the scale. So the reason I did the measure distance on Google Map, because it's much easier for you to set the scale on the maps now. So basically click this button. and click the first point and then second point. So I know this distance is 200 meters. So I just input 200 meters and then the scale is set. Okay. So the next step is going to select which camera you are going to use for the fail prevention. So for example, if this area is the detection areas of a waste, so what I'm going to do is that just click the camera model name here. So in the camera selection tables, you can use different filters to search the best camera for you. So we have the focal length, the resolution, the keywords, and the VC target distance. So if we go to the, if you know, just Mark has mentioned that all the thermal cameras is a T version. So we input the keyword T dash, and it will quickly filter out all the Hikvision thermographic cameras. And you will see different model names, part code. It will also show the resolution, focal length, and all other parameters. So for example, if I take the 25mm focal length thermal cameras and I select this camera, and the next step, you're going to set the camera name. For example, I will say 0.1, and you can set the mounting height. So if the camera is mounted on site at 4 meters height, and the mounting angle, maybe 10 degrees, and then here are multiple things you can choose. You can choose Hikvision is for the premium detection, so intrusion detection, land crossing detection. Customize means you can customize the size of the detection target, temperature measurement, and fail detection. So for fail prevention functions in waste recycling sites, we will use the temperature measurement, not a fail detection, because fail detection will only alert when the fail already happened. But what we want to do is early warning of the fail. So we choose the temperature measurement to the early warning of the events. And then you have to set the target size. So on average for waste recycling sites, we recommend maybe to start about 0.5 to 0.5 for a target. But it really depends on different materials and the different fail sources on sites. And I just take average size here. And then after all these parameters done, you just click add on the left top corner. Okay, and now one camera is added. And you can drag this camera and place in any place you want to install. For example, there is the install point here. I just change the angle of the cameras. So if you are not happy about the coverage, you can also manually now change the angles. Different angles will result in different detection distance. You see? Yeah. So usually about 7 degrees is the best coverage for thermographic cameras. Okay, now I add one camera here and I add another one camera to cover another points of the waste pipes. For example, waste pipes here. Okay, so this is for the fixed area detections, but some customers may have requirements. I do have a very large waste recycling size, and I just want one PDD cameras placed in the middle, and the PDD cameras can cover 360 degrees of the waste recycling sites. So we can also do this. But first of all, you need to add another camera, and then go to the camera selection. And again, we use the T dash to filter out all the thermographic cameras, and then select the PDD cameras. So for example, if I choose the 613T camera, okay, so here is the PDD cameras. So a PDD camera, you can set different presets, and you can set a schedule. For example, every 2 minutes, it will switch to another preset, and it will do like a patrol for 360 degrees. And then I place the camera in the middle. And here is the button, add preset. So this is preset 1, add the preset. And this is the preset 2, add a preset. Preset 3, preset, and preset 4. So now you will clearly see where the PDD cameras preset will cover. Okay, so this is for the temperature measurements. And there are some customers, they also have the requirements for the premium detection for waste recycling sites. So you can also set the VC detection functions on the thermal design tool. So again, let's add another camera. So after adding the cameras, you just go to the camera selection chart. And this time, because we are doing the premium detection, not temperature measurement, so you can just input the VC target distance you want to detect. For example, the perimeter is about 300 meters. So I just input 300 here, and it will quickly show you all the cameras which support 300 meters premium detection. For example, I choose this long-range bullet cameras. Okay, and then here you have to switch the temperature measurement to Hikvision. Hikvision means premium detection. Okay, so after done Hikvision, and there I can now get this camera out to protect this area. For example, this is the perimeter of the waste recycling sites. So one interesting you will find is that there's a gray area. So it's about 40 meters. I will zoom in a little bit. So it's a 39.4 meters of the gray area. So this is a brand area of the thermal cameras. And as you know, premium detection, one key important thing that you must make sure there's no blind areas. So no one can crowd this line without notice. So my suggestion has two ideas. So the first one, you can set another cameras to cover this distance. For example, 40 meters, and I will choose another cameras. And I will choose another 40 meter thermal cameras, for example, this one. Oh, sorry. I forgot you have to select the back camera again and click add. So before you select another camera, make sure you have to click the add button again. And then you choose the right camera. So if I select another short range thermal cameras, and then you just use this short range thermal cameras to cover the brand area of these thermal cameras. So this is option one. And as you know, Hikvision has Heat Pro thermal cameras, which is quite affordable price. So this kind of Heat Pro short range cameras can use it to cover the brand area of a long range body cameras. This is option one. And another option is you can use a clockwise direction installation. For example, if I choose another 300 meters thermal cameras to cover the second line of the perimeter, okay? So I just drag the camera to this area, and for example, this point, this is another perimeter, second perimeter of the site, okay? And then I add another camera and to monitor this side. And the last camera to monitor this side. Okay. So with this kind of clockwise directions, each camera will cover the brand area for the next cameras. So you can cover the 4 lines, and in the meantime, there will be no brand areas in this design. Okay. Now I'm going to show you the other functions of the thermal design tool. For example, if today I didn't finish my thermal design and I want to quit for a quick lunch, so you can just save this thermal design. For example, if I click save, and it will save it into a very small txt file. So, and you save this file into your local folder. Okay, now I quit this thermal design tool, and I will log in again. Okay. Now this tool is empty. So what I'm going to do, I'm going to import my solution. And then all the data will be retrieved back. into the design. Okay, so it's very convenient if you want to do maybe next day, want to finish job and close, you can close the web browser. And then after you done the, you finish the design, you can export this thermal design to like the PDF file or Word file. For Word file, if you want to do some like the edit based on the current versions, you can like the change it. But if you don't want to change anything else, so just use a PDF format and input a project name, project designer, and you can select the logo files if you have your own company logo. So you just like replace with your company's logos and click OK. And then you can generate a report like this. I'm going to show. Okay, and on the report, you will see the project's basic informations. And here is the map view. So you will see where your camera is. And please note, you can set different colors for different events. For example, I set on the thermal design tool, you can set the temperature measurement as yellow or different colors. You can set the Hikvision premium detection as different colors. So you will clearly see which color means which events. And in the bottom of the thermal design report, you will see a camera list. So it will show you the camera model names, camera basic information, mounting information, object information, and the distance. So you can use this list to place the order for thermal cameras. Okay, so that's it. It's a quite useful tool for you to quickly design your own thermal solutions on site. Okay, so thank you everyone. That's all for today's webinar, and we will share all the related materials to you after these trainings. Please check your email inbox.